bring on the phone and just got to go, so we can get going on the structure here, right? You can't do mine. How about now? Alrighty. Happy Monday again. Slightly behind here. I apologize for missing you Wednesday. It was a crazy day. I didn't get out of the hospital until like 3 or so. Nothing ever moves fast there, apparently. So we've got a couple things today. We're going to talk a little bit more about functions. I had a bunch of questions about the lab. Good questions. I want to go over an example, play with some more functions that way. Finish up the functions chapter, and then we can move on to strings. Strings don't take the longest amount of time, so it should work out pretty well. And then on Wednesday, we'll also go over the solution for project 1, which is due at the start of class. I know you folks are all here. You've heard me say it. no surprise here, but all the folks who emailed me, yes, it's due at the start of class, right? The start of class. So just repeat that a couple times in case I didn't catch it the first time. Make sure I can watch chat here. There we go. And then we'll talk about the next project on Wednesday as well. So should go pretty well. All right. Let me pull up PyCharm here. So for the lab, let's do the lab first. So that was going to be lab 4. Is that how we counted them? Yeah, lab 4. Let me start up a new project here. In our Git repository, GitHub 1, there we go. The lab 4. And use the right Python here. So the idea was taking project 0 and rewriting it with functions that store dictionary, right? Of let's build out the store, let's have users shop, right? That sort of thing. So a couple different functions then. I know we talked about maybe getting the product name was one of them for sure that we're gonna have to do when we were creating the item and when we were selling the item. So that for sure could be a function because we don't want to have the same code twice. So we could have a get product name, right? And this will ask the user, right, for a product name or something. Product name is an input of enter the name of the product. Sure. And then we can just return the product name. You could just return the input too if you wanted, right? Not too big of a deal one way or the other, but I do like having a step here usually, just so you can see the value in debug mode. Otherwise, it's really hard to see in debug mode. So we get the product name. That's fine. Should we start with the Project Zero code and like edit it, or do you want to just build it from scratch? Yeah, we can edit it. Sure. Let me go back and get my solution here then. Let's see. One. So here was Project Zero. All right. Let me grab all this here. All right. So getting the product name then, right? We can do that instead of this input for entering the item name, right? And then what do you want to buy? And can be the product name. Now, if we wanted those prompts to be different, right? If we wanted to leave them as like essentially separate prompts, we could have a take an argument here and keep what was different. So this is instead of enter the item name or what do you want to buy, we could give different prompts. I'm not sold one way or the other, which is all that much better here. I think we'll just leave it as get the product name, right? Enter the name of the product. Okay. Then other pieces here that could be turned into functions. Now we're not going to gain a whole lot out of turning enter the price of something into a function, but we could if we wanted to. Right? It doesn't have to be, but we could, right? So we could say, hey, here's the get our product price, and then if we're going to be doing substitutions here, we need to be given the product name, right? So if you tell me the product name, I can go and do the prompt here, right? So the price is going to be enter the value of, and then return the price of name. Right? This one's not super useful here. We didn't really reduce any code, but we put a nice name to what's happening. This sort of idea, we're breaking a big problem down into smaller problems, right? Enter the quantity. Now that one we're asking more than once, right? How many do you want to buy or enter the quantity? So that one we could turn into a one pretty easily here. So let's do a get quantity. So we'll have a define get product quantity given the product name. So then the quantity is this of the product name. Oh my goodness, hit the wrong scroll bar there. And we can return the quantity. Right? So we can get the quantity given the name of the product here. And then we're also doing that essentially down here, right? The quantity to buy of name. Right? So that one I feel like we reduced some duplicate code. Not perfect, but mostly reduce some duplicate code here. Okay. What else are we doing here? The adding to the dictionary. Sure. If we wanted to, go turn that into a function. Again, these are whether or not we're gaining a whole lot here, not really in terms of functionality, but we're having a nice name here, kind of adds to it. Yeah. This we're returning the quantity we just got out of the input here, right? I'm sorry. Where am I looking at? Saying it's a quantity is supposed to be like instead of quantity shouldn't be product name. Enter the quantity of, and this is the name of the product that we're saying, hey, here's apples. Enter the quantity of, and then we say apples. Right, and we're turning that one into an integer. We're like, how many of this do you want to buy? Right, enter the quantity of. Does that make sense? Okay. So we can, right, just for fun, really, this will be about add item to dictionary. Right, so given the name of the item, the product name, the product price, and the product quantity, and then we even need the dictionary to add to, right? So how about the, I don't know, store dictionary? So if I give you all of these things here, we can go and add. So we'll take our store dictionary, key of the product name, assign it the value of a new dictionary, given price and the product price, comma, another pair of quantity and the product quantity, right? So essentially the same line here now, right? But now we're doing this add item to the dictionary instead. So if we add the item to the dictionary, we can give it our store dictionary, we can give it the name of the product, we can give it the price of the product, and we give it the quantity to buy. Now, we've got a couple different variables here, and it's really easy to get these out of order, right? If I flipped price and quantity, that's not even quantity to buy. I'm just going to say quantity. It's really easy to get those out of order and cause trouble. So one cool thing we can do with functions here is you can name these arguments. So I can say, hey, the store dictionary is equal to the store. The price is equal to the price. I'm sorry, a product price, right? Product price is equal to the price. The product quantity is equal to the quantity, and the product name is equal to the name. So notice these kind of show up in red now. These are named arguments. So before, when you just give them in order, those are positional arguments. And we've seen that error, like, hey, function was required 2 positional arguments, found 1. You remember that from last week? We saw some errors. It'll error out if you don't give it the right number here. But if you don't want to do positional and say hey, the first thing matches the first thing, oh my cat, second thing matches the second thing, third thing matches the third thing, you can name them and say, okay, here's the store dictionary, here's the product, and then they don't have to go in order. As long as we give all of the values here, Python's fine with it. So generally, if you have like 2 variables, doesn't really matter, 3 variables, probably not, but like once you get to 4 or more, it's easy to typo these things. So this just helps us not typo, right? Or not even really typo, that's just would be a bug, right? Avoid bugs with passing arguments in the wrong order, right? If I flipped price and quantity by mistake, weird stuff would happen, right? It's not going to do what I expect it to do. So by naming them, it's kind of helpful, right? These are named arguments. Okay, so we can add them to the dictionary. Now, what's important here is when you pass someone a dictionary, they can go and modify it, right? Sure, we can go and change it because I gave you access to that store dictionary. So I can go and add new items to it. I can change the value associated with items in it here. So I don't need to be like returning the store dictionary each time because I'm adding to the one you gave me. So there's no having to assign things back here when we go. Okay. Now our total money, sure, we could add that in as a different function if we wanted. Right? We can make everything a function if we really cared to. Right? So define get total money. So get total money. So we'll have a money is a float of an input, and we can return the money. Sure. Again, not saving any code here. We're just kind of putting a name to what's happening here. Receipt costs, receipt items, cheapest item, most expensive item. Those are some of our little cheat ways of doing min and max, right? Get the product name, get the quantity. If it's not in the store, we don't sell that. All right, we've got some more things we can clean up here that aren't necessarily as easy, right? How about the quantity to buy, right, or the money needed? We could calculate total cost of something. So we'll get calculate, or what is it, total cost from unit price, or I don't know what we want to call that. We'll just say total cost of item. So to do that, though, we need the store dictionary, we need the item name, and we need the item quantity, right? So if you give me the dictionary, I can do that lookup. So my money needed then is the calculate total cost of, so I need to give it the store dictionary, the name, and the quantity to buy. So then the total cost then is my quantity to buy. Oops, I think we call that item quantity, right? Item quantity times the store dictionary key of the item name variable we passed, given the value associated with the price key, right? This two-dimensional dictionary. So we'll take the store dictionary you gave me, take the item name you gave me, take the quantity you gave me, do our multiplication by price, get total cost, and then we can return the total cost. Right? Okay. So we can calculate. Didn't really save a whole lot though, right? But that's okay. We did that here. And then our money needed, if that's less than our total or not. We could check for quantity if we wanted to. This one's a little harder because it's like we're using it inside of an if else here. But we could, right? So we could say, hey, I want to check, let's see, we have our quantity to buy, like get available numbers here. We could, right? So get quantity available, get define, get quantity available, given a store dictionary, given the item name. Right, we can return my store dictionary key of item name, key of quantity. Right, just to get that back out if we wanted here. Right, just an option. We don't need to, but we could. So given the store, the item name, we can get the quantity available. And just putting some names to what's happening here. So if you didn't really know a whole lot about this store dictionary and how it looked, right? I mean, if this is the only code we looked at here, we don't know how these things are being stored in the dictionary, right? We just know that the function will go and add it, and then the function will go and calculate the total cost, and the function will get the quantity available, right? And then that number here then, right, we're using that inside of this here as well, right? Get the quantity available. It's just changing how we're using the functions. So we don't need to use the dictionary directly in this part of the code here. We just have some functions that say, okay, hey, I'll get the quantity for you, or I'll get the total cost of items here. All right, cheapest item, money needed, sure. We got most expensive. Let's see, we appended it to, okay, we were using this one instead of the other one, right? So we can probably get rid of this because we used the money needed for most expensive min and max. Right, we did min and max for this one instead of the other items. Right, remember we doubled up, we had two different approaches, so I'll take that one out. Okay, and then to reduce the quantity here, right, we could have a function for that. We could have a reduce quantity available, given the store, the product name, and the quantity to buy. we can have a function for that. Given the store dictionary, given the item name, and given the quantity, right? Take our store dictionary, key of the item name, key of quantity, subtract from it the quantity. Right? You take those out. And I think that's it for the loops here then, right? Getting the quantity available, reduce the quantity available, add it to our costs, sure. And then we got min and max, right? Yeah. No, I mean, we could turn some of these print things if we wanted into other values here. Let's do that one here. So we'll call this print store, given the store. So you can have a function print store, given the store dictionary. And then for every item in the store dictionary, print the item as the key, store dictionary quantity, right? All right. So is this simpler? Not really. We have more code now with these functions, but if you just looked at this section here, if you didn't look at any of the functions, can we kind of tell what's happening? That's sort of the goal, right? Is the code like helping explain itself? Okay, I'm getting the product name, I'm getting the product price, getting the product quantity, adding items to the dictionary, getting the total money. All right, these are a little confusing, but that's okay. I don't need to worry too much about those. Get the product name, get the product quantity. If it's not in the store, we don't sell that. Calculate the total cost. If we have enough money, we buy it. If it's more than the quantity available, we only have this many. Otherwise, we take our money away, reduce the quantity available. Add to the receipt. The receipt part is a little funky here. We could probably clean that up, but print the items in our receipt. So we added a bunch of functions. Right? I don't expect you to have this many for the layout. Like get product name, probably get product quantity. These ones make sense because they're reducing duplicate code. So at least those ones. Right? We don't want to do the same thing twice. Right? Might as well use the function for that. These other ones were just for fun. Now, what's cool now, though, is the only time I use the dictionary is inside of the functions. So if I wanted to change how I store these things in the dictionary, I could change it in the functions. The rest of the code doesn't need to do anything about it or do anything with it. So I can essentially change how I'm storing these values if I wanted to. I could use, say, that dictionary key of the product name and then just a list of the first thing being the quantity, the second thing being the price. The functions won't care at all. Or I'm sorry, using the function. The rest of the code here doesn't care at all how it's stored behind the scenes. They just say, hey, give me the item name, give me the item price. Right? Give me the dictionary, give me the name, give me the quantity. So if you pass those as arguments, so what functions can allow us to do is sort of behind the scenes change how stuff works if we want to. So just like using int and using float and using input, we don't really care how they do the thing they're supposed to do, right? I mean, it might be interesting to go look it up at some point, but I just call a function like float and it does the thing it's supposed to do. It turns a string into a float, right? If you call add items to dictionary, the rest of our code doesn't really care how it gets added to the dictionary. As long as it can add to the dictionary, we can get those values back out later with the other functions, we're happy with it. So functions give us this level of abstraction. So it's one of our technical terms here for object-oriented programming, is that we get to work with stuff in an abstract manner. There's a function, it does something. We don't really care how it does the thing it's supposed to do. Now, if we're writing the function, yes, we care, because we have to write the function ourselves. But for anyone using the function, that abstract idea of, hey, reduce the quantity available, sure, we don't care. It'll reduce the quantity available. It doesn't matter how it does it. As long as it does what it's supposed to do, that's all we care about. If it gets the job done, we're happy. That's sort of goal here. So having functions then allows us to have that level of abstraction that we can change how it behaves behind the scenes later if we wanted to. Okay, so not all of it changed, but some of it changed here. that's kind of the idea with the lab, just to play with it, think of other functions we could have, kind of brainstorm some of those ideas. Passing arguments around is a little annoying sometimes, but like most of these need the store dictionary because that's where all the data is. So to get the stuff out, you have to tell it, hey, here's the dictionary, that's my store, and we can go from there. Okay, let's see, when we did functions here, oh, that's the wrong link, learn, there we go. We had a little bit left we didn't get to, right, for functions. So we talked about functions as objects. Right? You could pass a function to another function and it would call it. So if you don't use a parentheses, weird stuff happens because the function is actually an object defined in Python. It gets a little weird here. This scope of variables and functions idea, that inside a function, if I declare a variable like price, I only can use price inside this function. It doesn't exist after the function's done. So I have to return the value if I want it back. There's ways to get around it here. They're a little messy, and generally we frown upon using them. So we just most of the time follow that rule of thumb. If you're using a variable in the function, it only exists in the function. If you want to use a variable in the function, you have to give it as an argument, right? Your functions won't have access to other things that you don't give them as arguments most of the time. Again, there's some weird edge cases here. We can talk about them later, but don't care too much. That's our good rule of thumb here. So this idea of scope is where is the variable accessible, right? Where can we go get these variables here? You can have these global variables if you want. Again, it's a little messy here. I don't recommend it. Usually it's more work than it's worth to do global variables, but it is possible here. When it comes to finding the value of something, there's this idea of namespace. So when we look for a variable, it looks in the function first. If it doesn't find it in the function, it looks for it in the file. If it doesn't find it in the file, it looks for it in the Python library. So it kind of starts small and gets bigger and bigger and bigger as it does these lookups here. So if I wrote my own function for sum, given, I don't know, some list or something, and I just return 10, weird stuff will happen, right? I think we used sum here, right? The sum function. And I return 10 every time. When I call for sum here, it's going to use my function because it exists in the file. So generally, you don't want to rename, and like it's giving me a warning here, shadows the built-in name sum. Like, don't rename things from the Python library. Don't use those names here. So we don't want to do that if we can help it, because weird stuff will happen. Right? So it's a warning. You're allowed to. Python will let you do all sorts of funny things here, but we probably should avoid that. So I want to avoid duplicating those sort of names here. So avoid using built-in function names. That's supposed to be a dash built in, really? It grammar checked that one. I didn't know that was one word. Right, so this is bad. That sort of thing. That's all. So as we look for things, it looks the smallest scope first, which is inside the function, then the file, and then on and on and on beyond that. So we can do some fun things. Let's see, we look at function arguments. Yep. Depending on what we pass to functions here, it has access to the variables. Like we said, we pass the dictionary. I can go change the dictionary because I'm giving you the dictionary. I'm not getting a copy of it here, but certain variables here, if they are immutable, if I go and change it, it's only changed inside the function. If the variable is mutable, if it's something you can change, it stays changed. So giving it a dictionary, you can go and change the value of the dictionary. You can change what's inside of it, right? If I give it a float or a string or something like that, it can't change it. So did we look at that last week, changing strings? Per case string given some string. Right, if I said some string is equal to some string dot upper, and then I wanted to print some string, right? So let's do that first here. We'll say, hey, I want, name is Eric, I'm going to print name, and then I'll call uppercase string given my name. I'm going to print name again. So if we run these here, Eric gets printed out because we printed name. We called uppercase string. It printed capital E Eric because that's what it does. It prints the string. And then we printed name again. It's still lowercase. Right? Strings are immutable. You can't change them. You can make new strings in memory, and you can say, hey, the name variable equals a new string in memory. Go point to this other spot here. We can change it that way. But if I pass you a string, you can change it all you want inside the function. You haven't changed my original. Right? Because all we did is say, hey, this location in memory, right, where this used to be, give me a new string called this as uppercase, and then I now point somewhere else. Right? So if that string is stored somewhere in memory, right, we had like name, say that was like 27F or something, like some memory location, had the value Eric. Right? Inside the function, when it says, hey, some string equals some string upper, it doesn't change what's at 27F. What it does is that, hey, Python, give me a new location. How about 42B and store uppercase Eric? And then inside the function, some string points here now. We didn't change what's at 27F. So this location of memory still stores Eric spelled regularly, not all uppercase. So when the function's done, right, this name variable still points to that same location. We didn't change that. Some string was changed. We said some string, you don't point at 27F anymore, you point over here. But remember, name was still pointing over here. We never changed where name pointed. So it was immutable. We couldn't change the value of it here. Right? But if I had, say, like a name as a list here, we had, E, R, I, and C as a list here, right? And then we want to define how uppercase list given some list. We could say for, now remember, I can't do a regular for loop. I just say, for character in my some list, right? Because I get copies there with the for loop. So I need to go by index. Right? If I want to change the values, so for index in range, length of some list, if I have the index, I can change what's at that index, right? Similar kind of idea. When we had the for loop, we said for item in a collection, you can't really change item because it was a copy. So, but at index, then I can take some list at the index and say it's the value of some list at the index dot upper. Right? Take an uppercase version of what is there, store it inside the list at that location. So now if I want to print name, I want to call uppercase the name list here and print name again. We get the regular expected stuff here with the strings, but now when we do the lists here, it prints regular as the list was. We called uppercase list. When I'm done, my name list has been modified. The reason why that works is name still points to a list in memory. That list in memory is still where it was. We just changed what's inside of it. Right? I didn't change the entire list. If I tried to change the entire list, if I said, hey, some list equals a list of, I don't know, ABC, right? If I change the list itself, if I try and reassign the list, it doesn't change. Because what happened is, hey, make a new list in memory. Some list, you don't point here anymore, you point to this new list in memory. Oh, by the way, go change the things over here. The original name list down here still points to this location in memory. We didn't modify this anymore, we modified something else over here. So depending on what you pass it, if you pass it something that is mutable, it can change it. If you pass it something that is immutable, it can't change it. Right? So that's sort of the idea that some values, right, are changeable, like lists and dictionaries. If you want it not to be changed, you could use a tuple. Right? Tuples can't be changed. Or the other option you have is you can pass a copy of a list. We'll get to that in the next couple chapters, easy ways of going about that. So if I don't want them to change my list, I can give them a copy of the list instead of my original list. We got lots of options here. So this would reassign where some list points no longer modify the original. Does that make sense if we're doing that this way? I should add in more notes here. I'm sorry. I say it all out loud, but it doesn't always make it into the documents. Okay, so mutable and unmutable, right? Depending on what we want to do here, change values. Keyword arguments, this idea of these named parameters, right, is really cool. The other fun thing we can do with functions is we can give optional parameters here if we wanted. So let's say we're going to define, let's have a function for, how about print entire name, and you have to give it a first name and a last name, and then optionally we'll have a middle name. Now this gets a little funny here, but I'm going to say middle name equals and give it a value. So if you say it equals a value, that's the default. If I don't give you a middle name, we're going to assume it's blank. If you do give me a middle name, I'll know it's not blank, right? So we can just print, we want first name, and then we just want to comma separate these, the middle name, last name. Right, we'll print all of them out here. So I could call print entire name given Eric and Charneski. Now Python will not yell at me and say, hey, you're missing a required positional argument. It's perfectly happy with this now, because if I don't give it a middle name, it's assumed that it's blank. Right? So now I have the option here. I can add in a middle name, right, if I wanted, or just an initial or something, right? So if you give it the value, it takes it. If you don't get a value, you get the default. These are optional parameters. Now, the trick with optional parameters is they always have to be at the end of your parameter list. Right? If I wanted middle name to be optional, I can't put it in the middle. The reason is Python will get really confused because it won't know, is this really the last name or is it the middle name and I'm missing the last name? So it has to come at the end so that Python knows if you don't include it, you want the optional. So always be at the end. Right? So your positional or optional parameters have to be at the end of the positional list here. Because that way, if it's not included, Python knows, okay, this is the first thing, this is the second thing. Right? So those are optional or defaults. Those are fun. And you can have multiple ones here. Like all of your variables could be optional if you wanted. And then you can just have it be blank. Or you can give it one thing or two things or three things or four things. Those ones are fun. This args thing is really funky. Some people really like it here. It says you can give me any number of parameters that you want here. So it's essentially a list. Essentially, not exactly a list here, but it's close. So you can say, hey, give me anything you want. So their example here, hey, printing a sandwich. You get bread, you get meat, and then maybe you put some veggies on it, other things on it, right? So we're going to check and see, right, if the length of args is more than 0 with a bunch of stuff. And then for every arg that we have, every extra thing in the sandwich here, let's go and add in here. So if I want a sourdough with turkey and mayo, right, I'll get turkey on sourdough with mayo. Or I can give it a bunch of other things to put on that sandwich. Right? If you go down to Picasso, you say load it up, everything you got on there. Right? They'll load it up for you. Right? So it's optional. You can also do key value pairs as kwargs, keyword arguments. Right? Keyword arguments, keyword arguments, kwargs. Kwargs is fun to say. And then you can pass through particular values. Now the funny thing here is you name them and then the name comes back out. Right? It's a little funny syntax. Don't worry too much about it here, but you can do those, which is a lot of fun. Another fun thing, so when we looked at functions, we looked at returning values, right? Like you can return something. The rule when returning things is you can only return one thing. However, you know that tuples are a thing, and a tuple holds multiple values, but it's one bucket, one container, one collection. So if you return one tuple, you can put as many things inside of that tuple as you want, and you've only returned one thing. Right? So you can do some fun little shortcuts in Python. And this is, I'll define, let's say get lucky numbers. And we'll return 1, 2, 3, 4, 5. Right? What Python's going to do for you is add in the tuple here automatically. And now it's telling me, hey, it's redundant. Remove redundant parentheses because it happens automatically. If you want to return more than one value, Python will do this thing called packing. It will pack them into a tuple for you. Right? Say, oh, you can't actually return more than one thing. How about I turn it into a tuple for you? I'll be helpful. And then if you want to get lucky numbers, right, we'd have like number 1, number 2, number 3, number 4, and number 5 equal my get lucky numbers here. This will unpack them. Okay, so unpacking with comma separation. Separators, sure. So if your function returns more than one value, you can unpack them automatically with this notation. So you can see why this is nicer, right, than saying, you know, my number list or something, number tuple equals my get lucky numbers, and then, you know, number 1 is equal to my numbers tuple, number tuple index of 1 or index of 0, sorry, right? Like this would be kind of tedious. It works, nothing wrong with it here, but it's nice, and you know, Python gives us that shortcut to say, hey, you know, you don't need to do this yourself. I'll do it for you with the comma separator because I know what you mean. It's full of these fun little shortcuts. So you can pack and unpack automatically. Automatically packs into a tuple. Okay, let's see. I think that ought to work here. Let's double check. Make sure it runs, right? Oh, we didn't actually print anything, sorry. So let's print the number tuple. Okay, so it actually is a tuple, right? As we print it, right? What you get back, you can see with the parentheses means it's a tuple. I'm saying them differently, just I'm bored here, I'm sorry. So it's fun to say things. So that's a handy packing and unpacking way you can return multiple values. Unpacking and packing. If you want them as a list, you can return them as a list. If you want them modifiable, it doesn't really matter too much here, one way or the other. And then document strings are actually really cool. I'm not going to do anything with them because the goal of this class is to teach you how to program. If you want to learn how to write documentation, you folks are smart enough to look it up. I promise you, you're smart people, okay? But what's cool is you can add in notes about your function that will show up in the help string here. So if you write a function and you use triple quotes here, that starts a doc string, documentation string. And you can say something about it here. Some profs you might run into are nuts about these things. I don't understand why, but that's okay, right? I'm not them, okay? And they will demand that you have doc strings for everything. And that's okay, right? If they're giving you a grade, you can write a doc string. It's not the hardest thing in the world, I promise, okay? But I swore to myself, did I tell you that when I took my first programming class, I got marked down for my string being wrong? Yeah, so I think they're dumb for requiring you to do them. Right? They're great, wonderful things. They're very helpful. You know, some fun function. Sure. So when I start writing get lucky numbers here, lucky numbers, it should show it. Like it should pop up in the type ahead IntelliSense stuff numbers. It's not right now. Usually it'll pop up for you, and like that doc string will show up in my. Oh, here it is. There, as I hover over it, See, it says some fun function. The docstring shows up in this IntelliSense preview. Very useful if you're writing a library for someone else to use. If you're writing your own code for a project and no one else is using it, you've wasted your time, right? Because you probably know what it does because you gave it a good name, right? Because you're going to use good function names, not like A, B, and C. So again, I'm very biased against them. I apologize, but sure. If someone wants them, you can do them. And if you're writing a library for other people to use, please do them. They're fantastic, but it's not code, okay? Not code. All right. There's a built-in help function in Python, which is fun. So it'll print out the docstring of a function. Sure. So Python's kind of neat. So like in an idle environment, I think we looked at this real briefly. You can like type Python and it just runs here, right? Like print 10, and it does the thing. You can say help with, how about input? Input, given a prompt. Prompt defaults to none. Reads a string from standard input. Trailing white space is stripped. The prompt string, if given, is printed to the standard output without a trailing new line before reading input. Right? It's kind of fun. So if you write doc strings, you can ask for help on those functions. Right? Or like help max. Help on built-in function max in module built-ins. Max. Interval. Gives you a value. Sure. They're all well and good. There's nothing wrong with them. I'm not going to ask you to go write them here. Okay? And I think that's it for that chapter. Yep. Did I not turn on all the labs? Didn't turn on the labs. I'm sorry. Are you mad? Are you gonna be mad at me if I turn them on now? They didn't do it at the start of the chapter. Okay, I'm sorry. I didn't want to turn them all on ahead of time, but some people like to work ahead, and I should be better. I'm sorry. We'll go turn them on. We'll turn them on. It's fun. Okay. Cool. We good with functions? Feeling okay? All right. So then strings. Cool things we can do with strings. Strings are sequence types, right? So you can do this thing called slicing, this string slicing notation. That was lab, oh my goodness, I put all of this in lab 4. The rest of the function stuff. Is that okay? All right, I'm sorry. It'll all be out there. I'll do a new project. This is strings. All right, so with strings then, right, we knew we could get out one character at a time, right? So if I had my name here was Eric, we could say for, I don't know, character in name, print a character, sure. Or we could say for index in range, length of name, right? If you want to get it out, where's the key? We could print name at index here, right? This isn't new. We've done both of these, I think. Is it new? We're not sure. We did this one at least, right? We didn't do it by index? Yes, okay, I thought we did. Because they're a sequence type, a collection type, right? We can get them out by index. These should both give me the same ERIC. The next fun thing you can do here is you can get more than one value at a time, which is called a slice. You can get a slice of these. So if I wanted, say, the first 2 letters, I could print name. Instead of index of a particular index, I want to start at 0 and colon, I want to go up to, but not including index 2. So start value and then end value not including. Or end index not included. Is that better? Not index not included. Okay, so this is just E and R. I've sliced it here. If I wanted to start at index 2 and go up to but not including index 4, we could do that. I get the ick part here. Right? If I put in 10, still just gives me ick. So this doesn't yell at you if you give it more values than you have. Right? It just, all right, you started index 2, you wanted at least 10, all I got was 2. Good news. Okay, so generally you don't put in a bigger number than you have, but you could. Or if you knew specifically you wanted to go to the end here, we could say, hey, I want the length of the name. Right? We'll go to the last character for sure, starting somewhere. Right? Because the length is 4, there is no index 4, it's okay. Still works here. If you wanted to slice just a single letter, you could. Right? We could say we could print name sliced from 0 to 1. Right? We just get the character at index 0, 1 to 2, 1 to 2, 2 to 3, and 3 to 4. You could, you're just getting single slices. It's not the most interesting. Right? So we'll get ERIC repeated again, single sliced. And then we can take 2 letters, on and on and on. Right? So kind of a fun thing we can do with strings and slicing here is we can do a jumble. So we're going to take some string here, and then we want to take the, I don't know, chunk size. So if I want to jumble up a word, right, I'm going to take that string and I'm going to take so many letters at a time and jumble them up. Right, I can have a bunch of different chunks that way, right? So maybe I'll have a chunks list here, and I'll go and add a bunch of chunks to it. So we'll say, here's my start index is 0, and while my start index is less than the length of the sum string, let's take some chunks. So we'll take my sum string starting at the start index, and we want to go up to the start index plus the chunk size. Right? So if you want 3 letters at a time, 3 letters at a time, each chunk should be 3 letters. Let's start here and grab 3 letters. Okay? And then we'll take our start index and we'll add to it the chunk size. When we're done, we're going to return chunks. I guess it's not jumbled yet, but we want to just look at this for a second here. So if we have, I don't know, sentence. What's a fun sentence? Anyone like poetry? You do a daily affirmation? 1 fish, 2 fish. I think it's red fish, blue fish, isn't it? Blue fish? Sure. And then we want to get some chunks here. So we'll have chunks is going to be my jumble given the sentence. And how many letters should we do at a time? How many characters? 4? All right, let's try it. See what we get here. So I'm going to put a breakpoint in because I want to, I guess we can just print chunks here when we're done, right? We'll just run that. So we print this into some chunks. Uh-oh. We never added it. Oops, sorry. So we want to take chunks and we want to append this thing up here. Sorry. There, that would be helpful if we actually added it to our chunks collection, right? Otherwise, we have an empty list. There. Zoom in, come on. So 1 with the space, fish, 2 with the space fifth, havre, diffe, shibbe, lu, fish. We have chunks of 4. That actually worked out evenly, right? If we had like extra letters, we'd get 1 smaller chunk at the end, but this is not too bad, right? Now, let's go back and actually jumble it now. So we're just kind of looking around here. So let's say we want to pick these out one at a time. Right, so how about while length of chunks is greater than 0, right, while we have chunks, right, let's go print one of them out. So we'll get a random chunk, maybe, is, now we got a couple options. I think you guys found random choice, right? We talked about that before. Or we could again generate a random index and take that random index, that sort of thing. Let's go by index, because that might be fun. So we'll have a random index here then. Will be random.randint. We want from 0 up to and including the length of chunks minus 1, because randint includes, because it's crazy. It's kind of annoying. So that's why it's nice to have a help string, right? I guess. Sure. So we'll pick a random index, and then we'll print the chunks at the random index, and then we'll take our chunks and we're going to pop the random index off. Right? We can remove an item at a given index with pop. We look at that before? We looked at lists briefly. Get a couple nods. Okay, cool. So we'll print them out. Now, when we print, though, we probably don't want to be going down a new line each time. So let's change that ending character to just be nothing. Right? And then when we're done with all this, we'll print just to get that new line when we're done here. So now we don't need to assign chunks. We can just jumble the sentence. Right? We'll turn it into chunks. We'll jumble it up, print them out randomly, and go for it. Let's see if it'll jumble. There we go. Two reflish blue, one de fish. There we go. Just as good as Dr. Seuss. So taking slices here, we can do some fun things with slices. You okay so far? All right, so that's slicing. Other fun things you can do is you can give negative values, which is how many characters back from the end. So -1 is the last character, and if you give that as the ending point, it's not included. The start and ends are actually optional. So I could go in here if I wanted to slice something here. Let's go back to, let's take first 4 letters is going to be my sentence sliced. The start is optional. So if I don't include a start and end are optional, default to start and end, right? So if I don't give it a start location, it'll default to 0. I guess I should say 0, right? That's fine. 0 and the length of the string, right? So if I want just the first 4 characters, I can slice :4. It'll start automatically at 0, go up to and not including 4. So I'll get 0, 1, and 2, and 3 indexes chunked here. We can print the first 4. If I want the last 4 letters, right? I want sentence. I want to start at -4 and end at the end. For my last 4 letters. Let's see if it will work for sentence. Right? The first 4, 1 in the space. The last 4, fish. So negatives are characters from the end. Row. Right? So the end is optional. If you don't give it an end, you get the length of the string. Negative values, great. You can also do a stride. A stride is how many we're counting by. So we looked at stride when we did range, right? We said range from here's a number, start, here's a number, end, and you can count by. Do we do that? We did range. Same thing works with slicing. You tell it how many you want to count by. So if I want every other letter, so every other letter is my sentence from beginning to end, colon, stride of 2. Right? Start at the beginning, end at the end, give me every 2 characters. I'm going to print every other letter. Oh, we need the sentence, right? There we go. Here's every other letter. Well, that's scrambled up pretty nice. So the other, this is every other letter. Here's my sentence starting at 1, going to the end by 2. Right? Every other letter, right? If I start at index 1 and I go every 2, I'll get all the odd indexes. This will give me all the even indexes. Right? Oops. So we should be able to put this back together here then, right? So this is, if I can zoom this in, right? Oh my goodness, I cannot. There it goes. So O-N-E space, that's 1 F-I-S-H space, 2 space F-I-S-H space, right? We made a nice little scrambled sentence here, right? We've sort of encoded it. Is that the right word? It's not encrypted. Encoded it, something, right? We could pass out secret messages now, right? So let's do that. So let's take find make secret message given some string. So we're going to return my sum string sliced every other plus the sum string sliced every other starting at 1. Right? So we'll take the first half and the second half, smash them together, and they're pretty jumbled. So we want to take our sentence, turn that into a secret sentence. Secret sentence is make secret message out of the sentence. Let's print our secret message. Secret sentence. Now, this one's a little trickier to find where to start, though, but we know it's halfway, right? So O-N-E blank F-I-S-H blank, right? And back and forth, back and forth, back and forth. This is a little harder to unscramble because they're not stacked. It was nicer when it was stacked. But now we have a nice little scrambled string here. So if you want to pass secret messages around and have the teacher pick them up and try and read them in class, right? You just scramble them up and they're going to be really confused. I actually did this because I was a giant nerd for fun and wrote messages in a secret language because the teacher would do it on purpose, and he just picked it up and shook his head. It was really, I thought it was really funny as a teenager to make my high school teacher do that, but you can tell that's the way I'm a weird person. Like, this is the way I am, so you're not surprised. Can we take a secret message and unsecret the message? Can we do that? Undo secret message? Given some, or how about a secret message? Well, we need to slice it in half, right? Take the first half and the second half, right? And then we can start going through every letter. So let's try it. So we'll have the first half is my secret message. Now I want half, so I want to start at the beginning and I want to go up to the length of the sum message, secret message, 4 divided by 2, right, to make sure I get an integer value. Okay, that's the first half. And then the second half is going to be my secret message starting at the length 4 divided by 2 going to the end, right? And then my, I don't know, message then starts as an empty string, I guess. We could say for, how about index in range length of the first half? We'll take our message, let's add in here, right? The first half at the index plus the second half at the index. So take the first letter of each, take the second letter of each, take the third letter of each, take the fourth letter of each, throw them in here, throw them into message, turn the message when we're done. Do you think it'll work? So let's we print the secret message, and then we'll take the undo message is my undo secret message given the secret sentence. Sure. And I'll print the undo message. One fish, two fish, red fish, blue fish. We undid it, folks. We did it. Now we can pass secret messages around and no one will be able to figure it out at all. Encryption is the wrong word for this. It's not really encrypted. We just scrambled it. But, you know, it's fun. How do you feel so far? Using slices. That was one section out of strings. I promise the string chapter is not so bad. Not so bad. String formatting. We've been doing this, right, with these formatted strings, right? F strings. Now, you can do other things as well, which is fun, if you wanted, right? Sure. So this like gives you a default padding. So it gives at least 16 characters, right, as you're padding things. That's fun. You can use alignments for things. There's all sorts of crazy things you can do with these, like greater than signs, less than signs, filling given specific characters. Sure. Floating point precision, the rounding was nice, right? The colon 0.2f or something. Just go look it up, right? You don't need to memorize any of these things. Basically, if you want to format it a specific way, you can do it with string formatting. Just go look it up, okay? Nothing too crazy there. String methods, I think we've looked at a few of these maybe, right? We've done upper, we've done lower. Have we done find, to find a value in a string? Now, find is not all that useful on its own, right? So if we wanted to say, okay, let's, we'll print, just as we get back, we'll find in the sentence, oh, I'm sorry, sentence dot find fish. I'm going to find fish in the sentence, right? It tells me 4. 4 is the index of where that string is found. So we could have just said in, right? Like, hey, if fish is in the sentence, right, go do something. Find tells me not only that it's in the word here, but where that first index is. So if I wanted to find fish and I wanted to slice starting at the word fish, I could do that with, now I have the index of where it started. Sure. If it doesn't find it, you get back a, what do we get back? Find, I don't even remember now. I thought it was a negative value. I don't see that. Yeah, if you get back a negative value, it's not there. It's an invalid index. Otherwise, you get an index value, 0 up to, but not including the length here. That's what I thought. Right, so you can find particular values here, which is fun. You can find something at a given starting index. So, okay, once I found fish, let me find it again, let me find it again, let me find it again. Now, it's probably easier just to count if that's what we're going to do. Right? But if we wanted to find, if we want to do it the hard way, how many times do we say the word fish? Right? So we'll have a fish index is equal to sentence find fish, and we'll have a fish count, start at 0, and we'll say while my fish index is greater than 0, or equal to 0, I guess, because it could start there. So if we found a fish index of fish, right, it wasn't negative, we'll take our fish count, oops, plus 1, and then we're going to change the fish index to finding fish starting at the fish index plus 1. Right? If we find fish again, starting at the next index, right, it's not negative, let's add a fish count, find the next one, find the next one, find the next one. So we're working our way through, and we'll print the fish count here when we're done. So it should be 1, 2, 3, 4, right? Should be 4 if we did it right. Okay, we did it right. It's much easier to just print my sentence.count fish. But you can do fun things with find. Right? There's fun things with it. You can find from the right. Instead of finding from the left, you can start at the right side and work your way backwards. You can give it a start and an end here, all sorts of fun things. Comparing strings can be greater than or less than. We can use the in operator. Those are fine. The identity operator is funky. It's probably not going to do what you expect. Right? It will equal this, but it does not, is not that. Are they the same location in memory? Is the identity operator. Okay. So just use the equal sign. Don't use is. Right? Is the takeaway here. You can check if it's alphanumeric, if it's a digit, if it's lowercase, if it's uppercase, if it's a space, if it starts with something, if it ends with something. Cool things like that. Check to see digits for telephone numbers, those sorts of things. You can do all sorts of cool things. You can change them, right? These make new strings. They don't change the original, but they make new strings in memory. Capitalize, uppercase, lowercase, strip will remove all the white spaces, any spaces or tabs or enter keys around them. Title case will automatically title case, which is fun. Those ones are pretty good. String split and join. I think we can save those till next time because we got to run for lab here in a minute. Hardly get. Yeah, split and join. Let me show you the other formatting. So an older version of formatting was using these percent signs. I'm not a fan of them at all because the F strings are just so much easier. But you'll probably see this if you look at other people's Python code. If you see a percent sign, that means I want to substitute in what comes after the percent sign. So this is real small here, right? It says, hey, I'm going to substitute in, and then you can give it specifications that, hey, this is a string. I want to substitute in a string here. What comes after the percent sign is a string. I want to substitute in a digit. I'm going to give you an integer value. D for digit. That's the only reason I can remember it here. D for digits. F for floating point values for floats. You can give it floats. Right? Percent %F makes a whole lot of sense. I don't know why it wasn't I for integer. I'm still upset by that, but that's okay. They didn't ask me. So those are fun, and you can give it format specifiers as well. You can do other rounding, those sorts of things too. Exponential notation, hexadecimal notation, all sorts of funny things if you want with those formatters. Yeah. You can also use the format method. Again, still not as nice as the F strings, but F strings are a little newer, thankfully. They're just nicer. So you could essentially do the same thing, but you call .format, and then you give it the values to plug into the curly braces. You'll see this a lot as well. It's just ugly. Not as nice as F strings. So I give it 3 blanks, and I fill it in with 3 blanks with .format. Right? F strings are just nicer. You can give them named parameters. So like we got closer to F strings here, but now I have named parameters. So animal plugs in animal, headwear plugs in headwear, shape plugs in shape. Because as you get 3, 4, 5, 6, 7 of these substitutions, it's really easy to get confused which one is first, which one is second, which one is third. So we started doing named replacements before we got to F strings. So you'll see that as well. You can format them specific ways, right? Precisions for 0.2F works the same way, right? That same formatter for those. Yeah. All right, cool. You can also string format with a dictionary if you wanted. Right? Plug in key colon value, key colon value, key colon value. Right? The same like with the name substitutions essentially. This just looks terrible though. I hate this. But it works. So sure, they get the points. Okay. That is pretty good for strings. We'll come back next Wednesday then and look more at splitting and joining. Those are a little more advanced operations. So we'll practice some strings in lab. We'll do an exercise doing functions with strings. Essentially kind of this idea like we split them up and have some fun with them with secret messages, undo the secret messages. We'll do some fun things there, okay? All right, so we got 20 minutes. That's enough time to go get some more coffee because we've not had enough coffee. We being me, I've not had enough coffee. I'll get some coffee and see you for lab. Thanks, folks. Happy Monday.